Hello everyone, welcome back to KS Math Academy. In this video, you will learn the problems from class 10 chapter 2 polynomial. So first one, exercise 2.1. Look at the first question. The graph of y is equal to p of x are given below for some polynomials p of x. Find the number of zeros of p of x in each case. So first you have to understand that number of zeros will be equal to number of times the graph crosses or touches the x-axis. Look at your graph here. So in the first graph, we are not having any data crossing the x-axis. So number of zeros is 0. So no zeros are available in this case. Coming to the next one, here only one time it crosses the x-axis. So 1 0 is available for this p of x. And coming to the next question, so 1, 2 and 3. So 3 zeros. And for the next graph, we are having 1 and 2. So 2 zeros. And for the fifth graph, 1, 2, 3 and 4. So 4 zeros. And for the last one, 1, 2, 3. So 3 zeros. Now coming to the next exercise 2.2. First question, find the zeros of the following quadratic polynomials and verify the relationship between zeros and their coefficients. The question equation is x square minus 2x minus 8. So find the factors for 8. So 4 2s are 8. So x square minus 4x plus 2x minus 8 is equal to 0, forming the pairs here. So taking x outside, so x minus 4 and plus 2 outside, so x minus 4 is equal to 0. So x minus 4 into x plus 2 equal to 0. So x values are 4 and minus 2. So zeros are 4 and minus 2. So let us take our alpha value as 4 and beta value as minus 2 in this case. And coming to the verification process, you have to compare the given equation with your standard quadratic equation and list your values of A, B and C. So for listing the values, A is equal to 1 and B equal to minus 2, C equal to minus 3. So we know that sum of zeros is equal to minus B by A and product of zeros is equal to C by A. So using this we are going to find the verification process. So alpha plus beta is equal to minus B by A. So our alpha is 4 and our beta is minus 2 in this case, and b minus b by a, right hand side part. So minus of minus 2 divided by a value is 1. So here it is 4 plus minus 2. So 2 here minus 2 minus of minus 2, so plus 2. So verified. And coming to the next procedure, c by a, product of zeros. So alpha into beta is equal to c by a. So alpha is 4 and beta is minus 2 and c value is minus 8 and divided by a value is 1. So minus 8 is equal to minus 8. So it is also verified. Coming to the next sub question, second subdivision, 4x square minus 4s plus 1. So 4 into 1, 4. For 4 we have to find the factors and 2 and 2. So 4s square minus 2s plus 1 is equal to 0. Forming the pair over here, take 2s outside. So 2s minus 1, same 2s minus 1 has to be come over here. So minus 1 has to be taken out. So 2s minus 1 into 2s minus 1 is equal to 0. So s is equal to 1 by 2. Here also s is equal to 1 by 2. So our zeros are 1 by 2 and 1 by 2. So alpha is equal to 1 by 2 and beta is also 1 by 2 in this case. And for the verification process, list your values A, B, C. So A is 4, B is minus 4 and C is plus 1. And for sum of zeros, alpha plus beta is equal to minus b by a. Alpha is 1 by 2, beta is 1 by 2 and minus of minus 4 divided by a value is again 4. So 1 by 2 plus 1 by 2 is 1. Here 4 minus of minus 4. So plus 4 divided by 4, that is also 1. So verify. And for product of zeros, alpha into beta is equal to C by A. Alpha is 1 by 2 and beta is 1 by 2 and C value is 1 and A value is 4. So 1 by 2 into 1 by 2 is 1 by 4. So right side is also 1 by 4. So hence verified. And next question is 6x square minus 3 minus 7x. First you have to rearrange your equation in the decreasing order of power of x. So this is our equation. Now 6 3s are 18. For 18 you have to find the factors. So 9 2s are 18. So 6x square plus 2x minus 9x minus 3 is equal to 0. So here you have to take 2x outside. So 3x plus 1. Here minus 3 outside. So 3x plus 1 is equal to 0. So 2x minus 3 into 3x plus 1 is equal to 0. So x is equal to 3 by 2 and here x is equal to minus 1 by 3. So our zeros are 3 by 2 and minus 1 by 3. So let us take alpha as 3 by 2 and beta as minus 1 by 3. So for the verification process, list your values of A, B, C. So here in this case, A is 6 and B is minus 7, C is minus 3. So sum of zeros, alpha plus beta is equal to minus B by A. So alpha is 3 by 2, beta is minus 1 by 3. Here it is minus of B value is minus 7, A value is 6. And for the left hand side part, you take LCM. So 2 3s are 6 here. So 9 minus 2. So here it is minus of minus. So 7 by 6. So 7 by 6 is equal to 7 by 6. So hence verified. For alpha into beta, product of zeros, C by A. So 3 by 2 times minus 1 by 3 and here C value is minus 3 and A value is 6. So you can cancel these two. So minus 1 by 2, here also you can reduce your value. So minus 1 by 2. So minus 1 by 2 equal to minus 1 by 2. So hence verified. And for the fourth subdivision, 4u square plus 8u. So here you can take 4u as outside. So u plus 2 equal to 0. So 4u equal to 0, u plus 2 equal to 0. So u value is 0 or u value is minus 2. So our zeros are 0 and minus 2. So alpha equal to 0 and beta equal to minus 2. And for the verification process, A value is 4 and B value is 8. Since there is no constant, C value is 0 here. Alpha plus beta is equal to minus B by A. So here alpha value is 0 and beta value is minus 2. So here minus 8 by 4. So minus 2 is equal to minus 2. So hence verified. And for the alpha into beta, C by A. So alpha is 0, beta is minus 2, C value is 0 and A value is 4. So 0 into something is 0 and here right side is also 0 divided by something. So 0. So hence verified. And coming to the fifth subdivision, t square minus 15. So this can be written as t the whole square minus root 15 the whole square equal to 0. So you can use your a square minus b square formula. So a plus b into a minus b. So now our equation can be written as t plus root 15 into t minus root 15 is equal to 0. So our t values are minus root 15 and plus root 15. So our alpha value is minus. So our zeros, you can write your zeros are minus root 15 and plus root 15. Alpha is minus root 15 and our beta value is plus root 15. And for the verification process, A value is 1. Since there is no t quotient value, so B value is 0 and constant is minus 15. So C is minus 15. And here sum of zeros, alpha plus beta is equal to minus B by A. Alpha is minus root 15 plus beta is plus root 15. Here minus 0 divided by 1. Left side minus plus will get cancelled. So 0 is equal to 0. So verify. And for the next process, alpha beta, so C by A. Alpha is minus root 15 and beta is plus root 15 and C is minus 15 and A is 1. So my root 15 into root 15 is 15 and here we are having minus. So minus 15 is equal to minus 15. So hence verify. Next, sixth subdivision is 3x square minus x minus 4. So for number 12, 3 4s are 12. We have to take the factors. So 3x square plus 3x minus 4x minus 4 is equal to 0. Forming the pair, take 3x outside. So x plus 1 and minus 4 outside. So x plus 1 is equal to 0. So 3x minus 4 into x plus 1 is equal to 0. So x is equal to 4 by 3 and here x is equal to minus 1. So our zeros are 4 by 3 and minus 1. So alpha is equal to 4 by 3 and beta is minus 1. And for the verification process, A value is 3, B value is minus 1 and C value is minus 4. And for sum of zeros, alpha plus beta is equal to minus b by a. Alpha is 4 by 3 plus beta value is minus 1. Here minus of b value is minus 1 divided by 3. So here take LCM. So 3. So 4 minus 3 is equal to here minus of minus. So plus 1 by 3. So 1 by 3 equal to 1 by 3. So hence verified. And for alpha into beta, C by A. So alpha is 4 by 3 and beta is minus 1 and here C value is minus 4, A value is 3. So minus 4 by 3 is equal to minus 4 by 3. So hence verified. Now moving to the question exercise 2.2. Question number 2. Find a quadratic polynomial each with given numbers as the sum and product of zeros respectively. So alpha plus beta is 1 by 4 and alpha beta is minus 1. So before getting into this type of problem, you should remember the standard quadratic equation. If alpha plus beta and alpha beta is given to us, then our equation will become x square minus of alpha plus beta into x plus alpha beta is equal to 0. Now substitute your value. So x square minus of 1 by 4x minus 1 is equal to 0. So take LCM. So 4x square minus x minus 4 is equal to 0. Do cross multiplication. So 4x square minus x minus 4 is equal to 0. This is our required quadratic equation. Moving to the second subdivision, alpha plus beta is root 2, alpha beta is 1 by 3. So we know our equation as x square minus of alpha plus beta into x plus alpha beta is equal to 0. So x square minus root 2x plus alpha beta is 1 by 3. So take LCM. So 3x square minus 3 root 2x plus 1 is equal to 0. Do cross multiplication. So 3x square minus 3 root 2x plus 1 is equal to 0. So this is our required quadratic equation. And moving to the third subdivision, alpha plus beta is equal to 0, alpha beta is equal to root 5. So x square minus of alpha plus beta into x plus alpha beta is equal to 0. So now x square minus of alpha beta is 0x and alpha beta is root 5 is equal to 0. So our required quadratic equation is x square plus root 5 is equal to 0. So this is our answer. And for the fourth subdivision, alpha plus beta is 1 and alpha beta is also 1 in this case. So now our x square minus of alpha beta is alpha plus beta is 1. So 1x and alpha beta is also 1. So which is equal to 1. So our quadratic equation, required quadratic equation is x square minus x plus 1 is equal to 0. Coming to the fifth subdivision, alpha plus beta is minus 1 by 4, alpha beta is plus 1 by 4. So we know the formula. Substitute your values. So x square minus of minus 1 by 4x plus 1 by 4 equal to 0. Take LCM. So 4x square, here minus into minus plus. So plus x plus 1 is equal to 0. Do cross multiplication. So 4x square plus x plus 1 is equal to 0. So this is our required quadratic equation. Coming to the last question, alpha plus beta is 4, alpha beta is 1. So x, we know the equation, alpha x square minus of alpha plus beta into x plus alpha beta is equal to 0. So x square minus 4x plus 1 is equal to 0. So this is our required quadratic equation. Bye. Meet you in the next video.